Okay, surface area of composite solids. So the solid has like more than one, so let's put it together. So for example, find the correct to one decimal place the surface area of each solid. All measurements are in centimeters. Okay, so it's the first one here. It doesn't look like a regular prism. It's got looks like it's got two rectangular prisms put it together. So that's what its composite solids are. So what can we do? How do we start think about finding a surface area of this? Is again, same principle applies. You need to find how many faces this solid has. Okay, so I'm going to count front and the back, and then that's 2, 3, 4, 5, 6. The bottom one 7, and the back 8. So there are 8 faces, so it means that 8 areas we need to add up all together for surface area. Okay, so I think the hardest part is the front and the back, that this shape, L shape. So what I'm going to do, there's a couple of ways you can do this. You can divide this into 2 rectangles and then find the total area, or what I like to do is I'm going to make it into a big rectangle and then put this here like that. This is the part that you can see. This is the part. So what I'm going to do is I'm going to find the total area of this and take that one out. Will give me this. So what's the total area? That's a 20. That's a 16. And what's this one? Here is 10, isn't it? That's a 10. And this one was 12. So that's the same one. So it's 12. So what I'm going to do right now is 20 times 16, take away 12 times 10. That'll give me, okay, that's if you put that in a calculator, 320, take a 120, 200. So that is 200. And then I've got front and the back, there are 2 of them. Okay, so let's push it up a little. So surface area, because I'm just going to write 2 times 200. That's the front and the back shape. Okay, and then plus we got 8, so we found 2, so it'll be 6 more we need to find. So I'm going to put 6 more. One, 2, 3, 4, 5, 6. Okay, so I'm going to call this one as that one is my first one, second, third, fourth, fifth one is on the bottom, and sixth one, the last one, is on the back. Okay, so I didn't count the first and the front and the back. So first one, before we do all this, I need to know what these lengths are. Okay, 16 is for this and this, isn't it? That's altogether 16. And that's 10, because I know that's 10 here. So that has to be 6. Okay? And that's 20. So I'm going to use different color. 20. And that's going to be, that's 12 plus what will make 28. So that's 8 here. So that's a 12, that's 8. Of course, that's 8 as well. And I'm just going to put that's 12 here. Oh, maybe not. Okay, so that's what I've got. All right then. Let's start with the first one. That's rectangle here is a 6 times. Now that's a 15, 15, 15, 15, 15. So that's 15 here, So I'm going to go 6 times 15. So that's my first one. Second one is 12 times 15. Okay. Third one is 10 times 15. The fourth one is 8 times 15. The bottom one is 16 times 15. The last one is 20 times 15. So before I put it in calculator, I've got 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put it all that in my calculator. I will get 1,480 centimeters, square centimeters. Okay, excellent. So that's what first one was. Second one is this. Okay, so it looks like a sort of like box with a half cylinder on the top. Okay, so what was the formula for the cylinder? Do anyone remember? Cylinder, that's a cylinder. So a cylinder was what? 2 circles, top and the bottom, and the middle section is actually rectangle, wasn't it? So I'm going to put that into sort of opened up a little. It'll look like this. And that is the going around circle, which is 2 pi r, which is the circumference, and that's the h. Okay, well that's the radius r. All right. So that means 2 pi r square plus 2 circles, and this one is rectangle. Rectangle is what? Length times width. So 2 pi r h. So that's the surface area of cylinder. Okay, and we have to halve it because that's just a half of the cylinder. So what I'm going to do for the first part is half times the whole thing. 2 pi r squared plus 2 pi r h. Now I'm going to take the 2 out as common factor. Then I'll left with something like that, and pi r squared plus pi r h. Excellent. So that's the top bit, but what's the r and what's the h? R is half of 56, isn't it? That's diameter. So half of 56 is 28. So my radius is 28. The height is this part. Just think of it as if you lifted up the cylinder, that will be my height, and that's 40. Okay, so what I've got is this. So I'm going to put it all here as 28 square pi plus 40 times 28. So 40 times 28 pi. That's my first top bit. Okay, so that's what I've got. Now I've got 1, 2, behind 3, 4, 5. 5 rectangles to think about, because how many faces this one? Now I'm not going to count the top bit as a faces, but the bottom one is what? 1, 2, 3, 4, 5. So 5 rectangles that I need to put it on together. So I'm going to go total surface area equals, I'm going to go 28 square pi plus 40 times 28 pi, and then plus 5 of them. 1, 2, 3, 4, 5. Okay, so I'm going to go front and the back. So what's a front? 40 times 25, and then back will be the same, wouldn't it? You could just do times by 2 if you want to. And then on the right and the left, 56 times 25, 56 times 25. Now the base, the bottom, it's a 40 times 56. Okay, so if I do that, this one I already calculate. It looks like pi, and then add it all up, plus, I'm gonna just do this, just tighten it up, looks a little bit neater. 2 of 56 times 25 plus 40 times 56. Now, if I put all that in the calculator, I will get 13,021.59241 dot 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 dot. And it says, what was it? Question says 1 decimal place, so 6 centimeters squared. Excellent. So that's what you got. Okay. Next one. Okay. Now this is part C. Now what this is, there's 2 cylinders, one big one outside and a little one inside. It's like almost like, think of it as a toilet paper roll. Okay. So we need to think about, how many faces? So top, it's like a donut, top and the bottom, and then the rectangle, the curved one around the cylinder, the outside of the cylinder one, the rectangle, and the inside rectangle. Okay, so roughly 1, 2, 3, 4. I would say 4. Okay, so let's have a look at the top and the bottom, which is the like donut shape. Okay, so this is 15, and that's 20. And what are we looking for? Just the area of in the middle part. Okay, so that's what we have to find. So area of this shaded part will be big circle, take away small circle, wouldn't it? Yes. So big circle will be pi r squared, the capital R for the big circle R, take away little r. Okay, so what's the big R? It's 20. So 20 square pi, take away 15 square pi. Okay, I'm not going to put it as decimal yet because I'm going to lose some numbers. So I'm going to keep it as a exact value with in terms of pi. So if you put that in your calculator, so 20 square minus 15 square, you'll get 175 pi. Now that's just the top bit, and I'm going to double this because there are 2 of them, isn't it? So surface area, total surface area will be 2 times 175 pi. That's the top and the bottom. Oops. And then I'm going to find the what is it? I'm going to do it on the bottom here. Maybe I'll do it on the side. Outside rectangle will be the big one, big rectangle. So I'm going to just sketch here. Big rectangle will be 2 pi r, capital R, and then h. Okay, so it'll be 2 times pi times 20 times h is 36. The height, I'm going to show you. That was height was right there, 36. So that's my outside rectangle, which is, if you put that in a calculator, you'll get 1,440 pi. I'm keeping it as a exact value, just easier. at this point. And then inside rectangle is what? It's the same, but just a different radius, isn't it? 2 times pi times, what was the radius? 15. And the height is still the same. So if I do that, I will get 1080 pi. Excellent. So on the surface area, I'm going to add the 1040 pi plus 1080 pi. So if I add it all together, I will get 2870 pi. But put that in your calculator. What do I get? I'll get 0.37 something something, and then 1 decimal place, 4 centimeters squared. Excellent. So that's what I've got. Okay. So did I tell you this video is going to be a little bit longer than what it is? So if you want to have a bit of a break, turn it off and I will pause it and go and have a break and come back, because it's going to be a little bit long, because surface area is always going to be a little bit tricky, so I don't want to rush. So example 2, find the correct to the nearest square meters, centimeters, the surface area of each solid. All measurements are in centimeters. Excellent. So this is like a cone plus hemisphere, put it together. Okay, so how are we going to find? Now that's 60 is this one, the height here, and that's this part 11, which is radius. Okay, now what's the formula for the cone? Anyone remember? Can't tell you. Pi r l. L is the slant height plus pi r squared, because the bottom part is the square. Now we don't need this. Is that a square? No, circle. Yes, circle. No, we don't need circle, because that's been covered, because it got stuck with the hemisphere and the cone, the bottom of the cone. So we don't need that part. We only need this part. Okay, so I'm going to get rid of that, and that's my slant height. That's L, and I don't have it. I've got 60, I've got 11, but I don't have L. So, but luckily this one is right angle triangle, so we're going to use our good old friend Pythagoras. So let's have a look at that. So that's my 60, that's 11, that's my L. 60 square plus 11 square. Now if you put that in your calculator, you will get, which is 61. So my slant height is 61. Now that's a nice number, so we don't have to worry about that part. So surface area of this solid is the cone part, which is the pi times r is 11 times L, slant height is 61. Okay, so that's done. Now the bottom part is a sphere. Okay, what's the formula for sphere? Anyone remember? Is 4 pi r squared. Okay, so it's like a sphere, it's almost like 4 circles put it together. I think it looks okay, so we can remember it a bit better. So that's this one, but it's a half, it's a hemisphere. So is what, 2 pi r squared, because it's half of them. Okay, so I'm going to go with plus 2 times pi times r squared, 11 squared. Okay, so you can just put it all in calculator, but I just want to enjoy this exact value a little bit more. So I've got that, and I'll get 913 pi, and then I'll put in a calculator. I mean, you don't have to do it, but I just want to do that. So 2868.27 ... But it says to the nearest. You can see that there's a to the nearest. Okay, I should actually put highlight there. So make sure you put into nearest square meters, which is 2868 centimeters squared. Excellent. So that's what I've got. And part B of that is, if I push it down, you will see the picture. Now this one looks a little bit funny, but it's like a cylinder, but it's got a hemisphere sort of pushed it in. Okay, so you can see this part. Okay, so it's a hollow on the top up to here. So it's not quite cylinder, but you know, it looks like a cylinder there. So let's have a look at that. Hemisphere. Okay. What's the area of hemisphere? It's a 2 pi r squared. Remember, sphere was 4 pi r squared, so it's a 2 pi r squared. And then we got that, and what else we got? We have a circle. So we've got circle. I'm going to just add it on there. So pi r squared. So I have hemisphere there, and I have a circle, and then I have this rectangle all around, isn't it? Which is 2 pi r h. So if I think about sort of faces of this solid, is I've got hemisphere, and I have the middle body part of the solid, which is the 2 pi r h, and the bottom part is the circle, pi r squared. Okay, I think we're ready to do some numbers now. So surface area, total surface area will be adding all up, isn't it? Before you're rushing into putting in the numbers, let's just do some simple algebra here. What's this one? It's going to be, it's like 2x plus x, because that pi r squared is the same term. So I'm going to put then 2 pi r h. Now here r equals half of 50, 25, h is 50. So I've got all the information I need. So now I'm going to put that in 3 times pi times 25 squared plus 2 times pi times 25 times 50. So put that all that in your calculator. You will get 13,744.46786 ... and to the nearest centimeter square is 13744. Now this is, we're just looking at that, it's less than 5, so I'm going to ignore that. So that's my answer. Okay, excellent. Okay, it's going to be a little bit longer than what I expected, but I think you will appreciate it after I've done it all. Okay, example 3, find a correct to 1 decimal. We are back to 1 decimal, not to the nearest, 1 decimal. Okay, surface area, but all the measurement is centimeters, the same as before. So let's have a look at this. I don't know whether you can see it very well. Yep. Now let's have a look at how many faces. I can see the top circle, the bottom circle. Okay, so I've got small circle plus the bottom, the big circle, and then plus the middle part, isn't it? Middle part. Now middle part will be something like this. I'm just gonna sketch this. I'm a visual person. So that's the big cone, and I'm going to take the little cone away, and that'll give me, this part will give me something like that. Yep, that's what I'm going to get. So that's pi r squared, little one, and that's pi r squared. So what's r here? That's a 6. Okay, that's a 6. So my radius is 3 here. That's 12. So half of that will be 6. Okay, and that's a big one. We need to find a cone. Do you remember the formula? Cone pi r l plus pi r squared. So this is the pi r l part. So I need L here and I need L here. Okay, so this L is what? 5 plus 5 is 10. So I'm going to put 10 here. That's my L. And the little L is 5. So 5. So I've got everything I need. So surface area, total surface area equals the small circle, pi r squared, so pi r squared plus pi r squared, I just like to put the number in the front, and plus, now I've got to do a pi r l for this one, take away this little pi r l, so pi r for the big one is 6, L is 10. Take away pi, the little one r is 3, L is 5. Okay, so I've done that. So this one is 9 pi. Again, I'm going to keep it as exact form here in a pi term. 36 pi plus 60 pi, take away 15 pi. So that's 45 pi plus 45 pi, and I'll get 90 pi, and I'll put that in a calculator. I will get 282.7433 ... and I want it to be 1 decimal place, so 282.7 centimeters squared, and that's it, done. Okay, so that wasn't too bad. Now it's getting a little bit trickier now. Hopefully you can see the diagram here. Now it is like a cube in like a box, and it's got a hemisphere on the top. Okay, so I'm gonna actually have a look at this. I think the all around is just the squares on the bottom. Yeah, so the face of the squares will be 4 sides plus the bottom, so that's 5. Okay, 5 faces of the square, so I'm going to put 5 times 24 times 24. So that's the all around that part on the bottom. Now the important part right now is the top bit. So without the hemisphere, the top bit is like this, and it's got a big circle where the base of the hemisphere goes in. Now this we have to count it as a surface area. Okay, so that's going to be a little bit tricky, but it's not too bad because that's the length of the square, so which is 24. So the, what is it, radius is 12. Okay, so I'm going to find the area of this, which is, that's 24, that's 24. So I'm going to go 24 times 24, that's the area of the square. Take away the circle, pi r squared, so pi r squared. Okay, so when I do that, I will get 576, take away 144 pi. Okay, so that's the top, and I'm just going to add it on to here. Okay, So we're going almost like going from the top to the bottom, bottom to the top. So I've done all the squares around and the bottom, and I've done this part, just that. And now I have to deal with hemisphere. Okay, so let's have a look at the hemisphere. That's a 12. Okay, so what's a hemisphere? Is surface area hemisphere is 2 pi r squares, isn't it? Because a sphere is 4 pi r squares, it's a half of them. So it goes 2 times pi times 12 squared, because diameter is 24, and that'll give me 288 pi. Okay, so what I'm going to do here, I'm going to add 288 pi. So that is my surface area. Okay, so if I add it all together, what do I get? I'll add together 2,880 plus 576 minus 144 pi plus 288 pi. When I do that, I'll get 3,456, and that will be plus 144 pi. And put that in a calculator. 389 dot 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 dot, and to the 1 decimal place, 4 centimeters squared. Okay, so that's what I've got. Excellent. So make sure you practice this. And yes, the last one. This one looks a little bit, yeah, a bit more complicated than what we expected. But again, same principle. How many faces we have to think about? The top, luckily they're all square. Okay, so this is a square, that's a square. So we got top and the bottom squares. So 1, 2, and then all around 4. So 6. So there are 6 faces. Okay, we need to think about. So surface area, first I'm going to go the 6 times 6, the top, and the bottom 10 times 10. Okay, I'm done. Now the problem area, not really problem, I wouldn't like to say problem. Something that we need to think about is the actual, this part. Okay, so what I'm going to do is this. I'm going to just take this big triangle and then take away the little triangle on the top. Okay, so that's what I'm going to do. So I'm going to put this on the side there, take away. Okay, and then I will get, what do I get? This will give me this. Okay, so if I get that and times by 4, because there's a 4 of them, and then I add it onto there, I'll get the surface area. So let's have a look. So the base will be, I'm going to use different color. Base will be 10. I'm going to looking at the big triangle right there, and that's the height. Now slant, not slant, the side length here is what, 5, 8. 5 plus 8 is 13, so I'll get 13 here. Okay, and for smaller one, my base is 6. Okay, and then my side length is 5, and I don't have height. Okay, so how are we going to find area? Area was obviously triangle is what? Half times base times height. I don't have height here, so what I'm going to do is good old Pythagoras and to find this. So this height will be hypotenuse is 13. 13 squared, take away. Now this is 10, so this will be 5. Okay, that will be 3 here. So it'll be 5 squared. So 13 squared minus 5 squared will give me 169 take away 25, which will be 144, which will be 12. So the 12 is the height. And here, same thing happens. So height will be 5 squared take away 3 squared. So 25 take away 9, 16, 4. So that's 4. Okay, so I'm going to write the area for the triangle. Half times base times the height, take away half times base times the height, 4. So if I do that, I will get 5, 60, take away 3, 12. I'll get 48. So the little that looks like it's a trapezium is 48 centimeters squared. So I'm going to add 48 times 4 of them. There are 4 of them. Okay? So if I do that, what do I get? 36 plus 100 plus 192. When I add them all together, I get 328 centimeter squared. Excellent. Well done, people.